Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartural.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smartural.it/actuary. And if you'd like to make a tax-deductible donation to support our students, please go to smartural.it/help ISU actuary. Today and tomorrow I will post different solutions of the same problem I posted on April 10th, 2018. The problem is as follows. A device containing two key components fails when and only when both components fail. The lifetimes T1 and T2 of these components are independent with common density function f of t equal to e to the minus t for t greater than 0, which is of course exponential distribution with mean 1. The cost x of operating the device until failure is 2t1 plus t2. Which of the following is the density function of x for x greater than 0? So we will try to determine in this second solution, we'll try to determine the cumulative distribution function of the random variable x, which is equal to 2t1 plus t2. The joint density of t1 and t2 is given, each one of them is e to the minus t exponential with mean 1, so since they're independent, it's just the product of the two, which is e to the t1 times e to the t2 for t1 and t2 greater than 0. And in order to find the density, we'll first find the CDF, f sub x of x, which is the probability that x is less than or equal to x, which is the same as probability that 2t1 plus t2 is less than or equal to x, which we can figure out from the distribution of t1 and t2. And we'll do this by looking at the graph showing us where this event happens, the event that 2t1 plus t2 is less than or equal to x. And here it is. If t1 is on the horizontal axis and t2 is on the vertical axis, if you look at the line connecting the point t2 equals x on the t2 axis, the vertical one, and t1 equal to 1/2 x on the t1 axis, then we must be below that line, because along this line we have 2t1 plus t2 equal to x exactly. So below that line, the sum of 2t1 plus t2 will be less than or equal to x. So we need to find the probability of being in this region given the joint density of t1 and t2. And we just take the integral over that triangle of the joint density. So it's the integral from 0 to x, where t2 runs from 0 to x, of the integral from 0 to half of x minus t2, where t1 runs from 0 to half of x minus t2, of e to the minus t1 times e to the minus t2, dt1 dt2. So we calculate the integral with respect to t1, which is minus e to the t1, and evaluate it from 0 to 1/2 x minus t2. And we get, as a result, 1 minus e to the minus 1/2 x plus 1/2 t2. And we calculate the integral of this quantity multiplied by e to the minus t2 from 0 to x with respect to t2. So it's the integral from 0 to x of e to the minus t2 minus e to the minus 1/2 x times e to the minus 1/2 t2 dt2. And we now calculate the integral of that expression, which will be minus e to the minus t2 plus 2 times e to the minus 1/2 x, which is with respect to t2, this is a constant, times e to the 1/2 t2. Because the derivative of e to the minus 1/2 t2 is negative 1/2 times e to the minus 1/2 t2. And of course that 1/2 cancels with 2 and that becomes just 1 and a minus. So it's exactly the function that is the second part of the expression whose integral we calculating, and we evaluate this whole expression from 0 to x. So we plug in x and then 0 and calculate all the values, and we get minus e to the minus x plus 2 e to the minus 1 half x times e to the minus 1 half x plus 1 minus 2 e to the minus 1 half x, and that becomes 1 minus e to the minus x plus 2 e to the minus x, and minus 2 e to the minus 1 half x. Okay, then we combine the terms that have e to the minus x, and we get just one positive e to the minus x, and then the whole expression becomes 1 minus 2 e to the minus 1 half x plus e to the minus x. And the density is the derivative of that. Well, the derivative of 1 is 0, so then the derivative of the second expression will be negative 2 times negative 1 half times e to the minus 1 half x, so it will be just e to the minus 1 half x, and the derivative of e to the minus x is minus e to the minus x. And for x greater than 0, that's the density that we're looking for. Please remember, this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.